Okay, so again welcome to this course everyone, and thanks for joining. I hope you will learn a lot of things and a topic that is highly important these days. Yeah. So like you can see on the slide, so this course is kind of designed around having computing systems and making them more secure and sustainable. Yeah. So we will be talking more around secure and sustainable, but we will be looking some other aspects of computing as well. Okay. So you already might have seen my introduction. My name is Amit Kumar Singh. You can call me Amit, and I am from School of Computer Science and Electronic Engineering from University of Essex, which is in United Kingdom. So if you want to kind of know the geography of it, so you will see this is the map of United Kingdom, and here is London that most of the people know. Yeah, some people think UK or United Kingdom can be Uttarakhand as well. Yeah, so you have to tell like, okay, there is a London in UK. Yeah, then it's better. And University of Essex is just in the northeast direction. It's not far away. It's just 45 to 50 minutes by train. So that's fast train, and if there is a slow train, that will be like 1 hour. Yeah, so not far away, and lots of people who work in London, they live in this kind of place. Yeah, and the place is called Colchester. Yeah, so it's like University of Essex in Colchester. They have other campuses as well, but this is the main campus and where my department is there, or you can say computer science and electronics department is there. Okay. And it's called Essex because it's kind of one of a county. Yeah, there are many counties in UK, like here many states are there. Yeah, so here there's nothing like that, like University of Uttar Pradesh or University of, yeah, it's not like the name. Yeah, but this is county and then there is a university. So a bit of further introduction of myself. So I belong to a group which is called Robotics and Embedded Systems. So in my department there are mainly 4 groups, and this is one of the groups I belong to, and we have many academics and researchers. So I think we are like 8 to 10 academics, and there will be around like 25 researchers that will include postdocs, PhDs, and some master's students as well. Okay. For my research areas, so you can see I am mainly into developing technologies that can basically improve, so that can improve security, reliability, power and performance. Yeah. So there are several metrics we want to take care, yeah, when we design a system. So I work mainly on these 4 metrics, but as you might have seen the title of this whole module or whole lecture, we are going to focus mainly on security and sustainability. Yeah, and in a bit we will come like how sustainability is related to power and reliability. Yeah, so sustainability is, to me, has been given new term. Yeah, and it kind of includes some other aspects as well, and in addition to reliable and power efficient computing. So when I am developing these technologies, or you might also have seen, we use lots of philosophies, yeah, or lots of approaches. Yeah, so one thing is called like design space exploration. Yeah, so it's like you start with something and keep developing more and you end up with something. Okay, so I develop a lot of design space exploration strategies, and I also used AI based approaches. Yeah, and we will be looking into some of these in details later on. And you might also have seen there are biology inspired approaches as well. Yeah, so like genetic algorithm, yeah, or evolutionary computations. So in computing those things have also been used. I have used some market inspired approaches as well. So market is typically like you want to buy something. Yeah, so you want to bid, like you want to buy something, then you say I want to buy in this much. Yeah, it's kind of a negotiations. Yeah, so it's like you want to buy some share or some product, and then in computing it would be like how much you are willing to pay, maybe for this server, for that server, for that server. Yeah, So, this is kind of market inspirations. We will cover some approaches how this can be used. Okay. So, you can see like while I am developing these technologies, I am typically kind of designing some advanced embedded or computing systems, and these systems can be for several applications. Yeah, it could be like automotive, like a car. Yeah, it could be multimedia, so like your phone has a lot of multimedia applications. Yeah, you are playing games, you are watching videos and all those things. Okay, and this can be used for data centers. We will be looking into it, how it is used, and image processing and IoT as well. Okay, so these kind of technologies can be used across many applications. Okay. So, if in a nutshell, actually if you look in computing, we typically need 3 metrics. You can say secure, sustainable and high performance computing. Okay, and in this course we will be looking mainly on these 2, but typically high performance is always kind of implied. Yeah, so it's like you meet a performance requirement, and then on top you think how do you make systems secure and how do you make systems sustainable while meeting the performance requirement. So, you are optimizing for that as well. And these are the some kind of web pages. So, I have like 2 web pages, but this is from my university, and that one is second one is personal. You can look on those just to kind of see what else I work or what I have done in these kind of fields. Okay, and this is my email ID. So, if you have any questions or anything, you can always use this email ID to send me an email. Okay. I do not know if you already know the outline. Yes, because this was published on the website, what we are going to cover. So, first we will have introduction of secure and sustainable computing, and then we will have some system design considerations and operation considerations. So, I think we can quickly go to the end, just you can get the feeling what we are going to cover. And at the end you will also have the exam, that is on the Friday, 2 hours exam, and this will be like mostly multiple choice or fill in the blanks. Yeah, so you do not have to describe everything in details. Okay. Out of all these contents, so there are three lecturers you might have seen. So, myself, Dr. Momita and Dr. John Joes. Yeah, 3 of us will cover these different aspects. Yeah. Okay, so this is where I want to start with, just to kind of know a little bit like what you are doing at the moment and what's your name. Yeah. So, I think just give a moment, if there is internet it will change to something. Yeah. Okay. So, if you have phone, yeah, you have phone. If you can open a browser, you can just type, yeah, polev.com/Amit Singh 510. I think you can do by the barcode, but it might be too far away. So, this polev.com/Amit Singh 510. So, you will get a box, yeah, and then if you can type your name and what are you doing at the moment. Yeah, like you are doing you are PhD student, undergrad student. So, this is to know basically how fast and slow I can go in the contents. Yeah. Okay, so like I said, I just wanted to check basically what are you doing at the moment, so we can discuss later on accordingly. Yeah. Okay. You can keep doing, I will do some changes in the setting. I think something has changed. Okay, so I see some of you are doing MTech and lots of research scholar. I also recall some postdocs. Yeah. So actually this kind of interface gives opportunity if someone online as well wants to participate. Yeah. Okay. So junior research fellow as well. So I think we have mixed up audience from MTech, research scholar, junior research fellow or research fellows. Yeah. So I mean what like in the lectures we can do, we can be like a bit more introductory, but for research scholars and research fellows we can go in bit more details. Yeah. So you can try to apply the same concept into your research. Okay. Good. Hopefully it works in the slides as well now. I will just check. No, it doesn't. Don't worry, that's fine. Okay, my second question, again I will go on the web. Okay, so next thing I wanted to know, like what kind of field you are working on, yeah, and like what is your interest. So maybe like even if you are working on something, but you may want to learn something more about another topics. Yeah. Okay, this one again has some problem. Hopefully you can see the interface. Yeah, you just refresh the same interface and it will just populate with different screen. Okay, AI and ML, X apps development, 5G network. Good. So secure machine learning accelerator design. Okay, good. Hardware security, IoT and edge security. So we will be covering most of the topics, and as you know, these days nobody can live without AI and ML. Yeah. So everybody applies in their own field. Yeah. I mean, sometimes it's great, it gives good results, but there could be situations it doesn't give good results. Yeah. So you can be better with heuristics approaches. Yeah, or some other well established maybe static search. Yeah, like evolutionary computations and all those. Yeah. So communications, I think I will be covering less of communications, but Dr. Momita will cover some communications part. Yeah, so you will have some learning of that as well. Resource management in unmanned aerial vehicular networks. So I will cover resource management in kind of a system design. Yeah, like multi and many core systems. Maybe Dr. Momita will cover something, I don't know. So UAVs. I don't know if it's part of the project, so it's not from my side. Yeah, but it's for me UAV is kind of another resource constrained device. Yeah, it's battery operated, you cannot put a big processor on it, otherwise battery will be dying. So we will be doing resource management in resource constrained environment, and you can use the same approach other places as well. Yeah, so to me it's just another kind of IoT, or you can say embedded system. Yeah. So the same concept can be applied. Okay. Okay, 6G. Okay, again not my topic, but Dr. Momita's topic. So hopefully there will be some kind of coverage about that. Okay. Okay, good to know. So a lot of you are interested into kind of a small scale device or resource management or secure hardware design or communications and all those things. Yeah. Okay, so good, you are at the right place. Okay. Yeah. Okay, I don't think this screen works, so I will go to the other one. Okay, now let's look the typical computing systems landscape. Yeah, because we said we are going to cover secure and sustainable computing. Yeah, so what is this computing landscape? What is computing systems landscape? So we have taken some contents from this website. So you can see here there is a lot of devices we are surrounded with, yeah, and these are typically called edge devices, yeah. So we already are surrounded with, you can say, this projector, there is AC, there will be a kind of microcontroller inside, in your laptops, in your phone, these microphones, everything, yeah. This is screen, or these are edge devices, yeah, and a smartwatch and any other thing that we are surrounded with, yeah. So and these devices typically have some sensors, they detect something and then they do some actions, yeah. For example, this air condition, yeah. So when you kind of try to decrease the temperature, so that the sensor will detect it and then it will do some actions according to that, okay. So this is one kind of computing landscapes, and if you look how many devices we have in the world, there are billions of them, yeah. So you can imagine, just maybe inside IIT Guwahati there could be maybe 10,000 devices, yeah. So worldwide there are many billions, and we are coming to that, like how many billions approximately we have at the moment, okay. After this there is another kind of computing layer. This is typically called like fog or nodes, or you can also say servers, yeah. So within IIT Guwahati again there will be lots of server rooms, right, and you may imagine why they are, yeah. It's typically because you cannot do everything on these devices, yeah. So some of the things are captured, they are sent to the server, stored, sometimes just stored, or sometimes when they are reaching there is some processing done as well. The main reason is these devices do not have memory capacity, or they are battery operated. So if you try to do everything there, it will not be done in a fast way, or it's going to take basically very long time, yeah, okay, or the battery will run out. So you have another layer that is called, you can say, servers, nodes, or fog layer, okay. And if you see their numbers, they will be in millions, yeah. So they are not like many billions, yeah. So maybe there are 2 or 3 server rooms, and each of them may have like maybe 50 or something, yeah. So you can imagine. So this is not too many. On top of this there is another layer of computing, yeah. So there is data centers, okay. So you have seen everybody uses data centers, yeah. Again the reason is some computation cannot be done here, so it's sent to the server, but there are still some computations. If you try to do those on those servers, again it's going to take a lot of time, yeah. So you send your computation to data centers, or you can say to the clouds, yeah. And if you look across the world, we will not have more than thousands, okay. So if you look, these big companies, Google, Facebook, Amazon, or Microsoft, they all have their data centers, okay, and their numbers will be just in thousands, okay. So this is typical computing systems landscape, okay. So now, as the topic says, we are going to look secure and sustainable computing, okay. So we will be looking like why security is important across all the computing layer, yeah, and why sustainability is important. So you saw, like I said, what are the kind of computing devices, and these computing typically is happening on electronic device, right, semiconductor based electronics. And over the time, if you look, we have got more and more electronic devices, okay. So here you see, if we look like in 2018, we had like 18 billion of devices, okay, and those are into different compartments, yeah. You can say like some smartphones, some machine to machine, some TVs, PCs, tablets, okay. So these are different categories. And if you look just 2023, we have like 27 or 28 billions of electronic devices, okay. So this includes everything in from the last slide, yeah, all the edge devices like we are surrounded with, servers, and the data centers as well, okay. So you can see, you can kind of imagine at the moment we should have around 30 billion electronic devices, yeah, okay. And this is a report from Cisco, and you can basically, if you search simply this on internet, you will find this report. maybe they have more updated version. So I created this slides, couple of months back, and you can see this is the increase is like 10% per year, okay. But at the moment you might be seeing the news and everything, right? My feeling is this is increasing at a much faster rate, yeah. You can see everybody now wants to create their data centers, like OpenAI, you might have heard, yeah, you might be using ChatGPT. So you can see like they also want to create their data centers, so they want to just rack up whole servers and create data centers. So the rate is going to be much faster than 10%, okay, and everybody is towards developing smart cities, smart homes, okay. So on one side you can say, okay, we are doing great, it's kind of helping human, but we will see it's not helping the planet, yeah. So it's not kind of sustainable, but how we can make it sustainable even though trying the same things, we will look those kind of things, yeah. So some more statistics. So if we look like maybe just in a few years, like 2 or 3 years, we will have approximately 50 billion devices, okay. That's a lot, yeah. So you can see like we have like 6 to 7 billion people, and there are 50 billion devices. So each of us has lots of them, yeah, 7 to 8 average, okay. But we don't have 7 to 8, but you imagine like in companies there are like 1,000 employees, but there's a big office, there is a data center, there is server room, so they own maybe hundreds of them, yeah, but average comes a lot, okay. I think there is also some prediction there could be 1 trillion devices in 2 decades, yeah. So you may know some companies that produce lot of small scale devices, yeah, like ARM, ST Microelectronics, even AMD, NVIDIA. So these are producing like in the batch of millions, yeah. So even I think these predictions has been from NVIDIA guys, yeah, Jensen Huang. So there could be trillions of devices, yeah. So you might know the story like NVIDIA was once trying to acquire ARM, and ARM is the kind of biggest producer of microcontrollers, yeah. Even the phones that we used, most of the chips behind it, it's from ARM. So they were thinking to produce huge amount of electronics and to sell everywhere, okay. So very kind of in 2 decades we will have trillions of these, and maybe many more thereafter, okay, yeah. So many electronic devices. So when we have all these, you can see like if we have so many electronic devices, this all will need electricity, yeah. And this electricity is produced by burning fossil fuels, yeah. So there is carbon emissions and all those things. So some sort of sustainability comes into picture, yeah. And when there is so many devices, if they are connected, they can be attacked as well, yeah. So we have to look the security aspect as well, and we all know there is kind of performance is the need, yeah. First, like okay, if you put anything, you have to make sure it's fast enough, yeah, okay. So this is kind of the need when these devices are exponentially increasing, okay. So I have here listed some important metrics, yeah. So performance, the timing is the first one that everybody wants to care, yeah. For example, if I'm clicking like for the next slide, it should not take 1 minute to load, yeah, like that website, yeah, we took 1 minute to load. Everybody wants performance, which means this could be many issues, yeah. It could be the network bandwidth, or it could be my processor is very slow, it depends, okay. Again, after performance we want energy efficiency, yeah. Again it has 2 aspects. If your device is battery operated, yeah, like my phone or laptop, we want the battery to last for a long time, but if it's not, like a server or data centers, they are taking electricity, yeah. So your electricity bill should be as minimum as possible, and that's possible only when you reduce the energy consumption during the operations, okay. Temperature is another very important metric, yeah. It's kind of not playing direct role into kind of your kind of energy or performance, but you may feel like if you're using your device or phone, if it becomes very hot, right, you don't feel good. That means it's important for user experience. Yeah. So temperature is important for user experience. Another thing could be, so if your like device is operating at high temperature, you may realize your phone or the device will not last for a long time. It will fail very quickly. Okay, there is some sort of research on it. So if you operate at high temperature, your electronics will fail maybe in 2 years rather than 5 years. Okay, so it has some kind of reliability aspect as well. Okay, so the next one basically kind of is reliability. Like I said, temperature is related to reliability. Yeah, so it's like how long your device will last. But reliability has another aspect as well. So it's like one of the components fails. Yeah. So for example, in your phone there is many things. Yeah. Like my Wi-Fi dongle failed. Yeah. Then I mean my Wi-Fi module failed. Then I got a dongle. Yeah. So there should be a way to work around. Yeah. So if like one component or one processor fails, how can you make sure to shift the workload to something else so you can still work around. Yeah. So this is a nice example today. Yeah. My Wi-Fi module failed, so I got a dongle, and then I shifted the workload on the dongle, so we can get it done. Yeah. So basically you don't need to replace the device immediately if you can do fault tolerance. Yeah. Some fault happens, how do you handle it? The next one, security, that is very related to this module. You know security is important. Yeah. You don't want your password to be kind of known by anyone. You don't want your data to be leaked. Yeah, lots of things. Okay. Okay. I think I have this again question. I don't know if it will come on the screen. Let's see. So like I said, I will build up slowly. First we should get the introductions done, and then we will go into more advanced topics. Yeah. Okay, let me go to that screen. Yeah. Okay, I see the text box. So which metric or metrics you think are the most important? Yeah, we covered 5. Yeah, performance, energy, temperature, reliability, and security. Okay, energy and power consumption, performance, reliability, cost. Okay, I think cost is interesting one. Unfortunately, I didn't put in the previous one. Thanks whoever has put it. Yeah. Because cost is something that drives everything. Yeah. If you make a kind of security solution that you sell for millions, nobody will buy. Yeah. So everything has to be cost effective. Temperature, okay, performance and security. Good. So I see some of the things around the same lines you are saying. Yeah, security is important, reliability, performance, efficiency. Yeah. But yeah, I think that someone that brought cost is good, because everything is driven by cost. Yeah. Imagine like I said, someone sells you some security solutions. If it's very expensive, nobody will have it. Yeah. So it should be cost effective. And cost effective means it should be kind of lightweight. Yeah. It should not have complex logic. Yeah. It should have kind of some small software, small logic. And if it comes in form of hardware, yeah, so that hardware module should have very small footprint, yeah, very small area, because you pay to the companies that manufacture based on what is the size of the chip. Yeah. And then if you have extra component for security, then you are going to pay more. Okay. Okay, so like what metrics you think is the most important? So to me, actually, it kind of depends. Yeah, what kind of systems you are using. Okay. So for example, if you are in a car, yeah, like the car that are not connected with internet, right? There is no problem of computer security. Yeah, nobody is going to be connected with your car. Forget the more advanced car, yeah, now they are connected with cloud and internet, yeah, but those ones they are fine, they are working fine, yeah. So in that one the most important will be performance, yeah. So and that comes like kind of people call it safety critical systems, yeah. So critical because you must respond to some request within a certain time, yeah. So for example, if you apply the brake, it should respond within microseconds, yeah. So you are applying the brake, then there is some controller that is doing some actions, yeah. If it takes like 1 minute, then you are already crashing a lot of people, yeah, and you don't want to kill, yeah. So these kind of critical systems, they go under a lot of, you can say, certifications, yeah. So it's not like you build a car, just sell someone, it has to be certified by government bodies, okay. So for a kind of a system that is running autonomously, kind of that thing is more important, yeah. Again, when it comes to more EVs, yeah, electric vehicles, now they are on batteries, right, and then kind of energy efficiency is important, yeah. So you don't want to charge your electric vehicle every 1 hour or something, yeah. So if you take less energy when it's running, then it can last maybe 200 kilometers, yeah. So again, it depends on the scenarios, okay, yeah. And maybe there is some system like maybe on some kind of extreme situations like on mountains or something, right, then maybe it's just taking some data, processing it there, yeah. And maybe occasionally when there is maybe some storm or some kind of situation, it has to alert, it sends to the basically some servers or something for further alarms, yeah. So in that case, energy efficiency is important because there will be a battery that will be powering, and when this communication is happening, then it must be secure, yeah. What if someone sends maybe like, okay, there is a problem, there is some landslide or something, but someone hacks the data in the middle and then says everything is fine, okay, then there is problem, okay, yeah. So it depends on the situation, so different metrics can be important at different places, but if you consider our normal just laptop or our phone, yeah, I would say in the phone everything, all of these is important, yeah. So when you open an app, it should be fast enough, yeah, and it should not take a lot of battery, yeah, you don't want to charge, and you don't want your phone to heat up a lot, yeah, and you also don't want your phone to just last 1 year, yeah, or 2 years. Maybe some people want it, yeah, because you want to change the phone, yeah, so you want to upgrade, yeah, but majority you don't want to change the phone, yeah, you want it to last as long as possible, yeah. If you are on contract, then you want to change, yeah, so our postpaid ones, yeah, okay, and you always want to be secure, yeah, when you are putting some data or you are doing anything, you don't want anybody to take your data, okay. So I would say it depends on the kind of environment in which you are, okay, good. I think we need to go back here again. Okay, so I think I am going very slow, hopefully it's fine, yeah. We will go a bit fast later on maybe when we think like, okay, this is kind of, you know about it more, but this is to build up basically how we set up the importance of the field, okay, or we set up the whole context in computing environment, okay. Now we come to introduction to secure computing. Although we have talked, but we will go in kind of more formal definitions and how people have defined and like why it is important and all those, okay, a bit more details. So if you kind of want to kind of say what is secure computing, you can say this is about protecting systems, data and people, yeah. So we talked about systems, you want it to be secure, but sometimes systems are not doing anything, there is just data stored, yeah, and it is also to protect people, yeah, okay. So just remember, like at the top level, this is not just systems, yeah, this is about data and people as well, okay, and we will come to more formal definitions and importance a bit later. So why secure computing matters, yeah, why it is important. Okay. So you might already have seen lots of attack happening on different institutions, yeah, like somebody is stealing some kind of financial data or some sales data or credentials, yeah. So some of the whole organization is closed, yeah, like maybe whole hospital or maybe whole airport network, they are closed. Okay. And if that kind of things are happening, there is a cost to fix it, yeah. So, and this cost is projected to exceed like 10 trillion annually by 2025, just this year. Okay. So this is a lot of money, yeah. I don't know if you heard this CrowdStrike company, yeah, there was some update of some systems and then everything was shut down, so like many airports and everything, although that was a security company, but they did other way around, yeah, but things can go wrong. And to fix it, it took a lot of money, yeah. Not everybody will know, but those organizations will know. Okay. And recently, I think in UK there has been some attacks on like some kind of retail stores. There is kind of organization called NHS, the National Health Service. There was some attack on that, and then it took a lot of money to fix, yeah. And fixing it can be in two ways, yeah. Sometimes the system is just basically maybe it has been made not to work in the way it is working, then there is a team that can go and restart and things may work, yeah. And another way to fix it, if the cyber crime happens, people want some money from it, yeah. Nobody, I mean, you can say like hackers or cyber criminals are not working for fun, yeah. They want money, okay. So they attack system and then they will kind of negotiate, you give me that money, I will kind of not do anything, yeah, or not release the data in public, okay. So sometimes there are many multi-million dollar deals, yeah. Organizations have to transfer the money to these basically you can say cyber criminals or very intelligent people to kind of sort these things, okay, yeah. So that is, this money counts everything, okay. And these breaches, you can say they cause financial damages, there is reputational damage, right. For example, you are using some kind of website, right, maybe Instagram, Facebook or something, right. If your account is hacked, then you start believing it less, right. It has lost its reputation, that means they are not securing the things where they are storing, okay. And there is also legal damage, yeah. So like if something happens to you as part of some organization, you can basically sue the company, yeah, and then they have to pay in that terms, okay. So there is lots of basically problems that may happen because of the cyber security issues, okay. I think we already covered. So this is just an example, ransomware shutting down a hospital system. So this was a case in UK and many other places as well, okay. So ransomware is like it says, there is some kind of malware that is put into your system and then they have kind of control of all the systems, then they are going to kind of ask, give me this much money, otherwise I will shut down your system. So sometimes you think like people are bluffing and you say okay, go ahead, and then they shut down your system, okay, and then you lost a lot of money, yeah, like pays their disappointments and all those systems, okay. Okay, so you can see how important it is. Okay, so what is secure computing? I think I wanted to hide this first just to ask what do you think in your view is secure computing? So can any one of you just tell your definition of secure computing? Yeah, anyone? I think I already have put the definition, there is not much point, so let's look into it. I wanted to kind of put in the same format, yeah, like previously, yeah. So I would say secure computing is basically ensuring three entities, yeah. So the first one is confidentiality, and then integrity and availability, yeah. So this is also sometimes is called CIA triad, yeah. So you know CIA in US, right? the Central Intelligence Agency, something, yeah. That's easy to remember, yeah, but it's the full form here is different, okay. It's confidentiality, integrity and availability. So what is confidentiality? Like the name says, right, you only give authorization only to the people who needs it, okay. So only authorized people should be able to access, okay. For example, the Wi-Fi network that you have in the campus, yeah, I needed to get an ID and password, yeah. If anybody can come in the network, if the network is very open, they might also do some damage, right. Integrity, second one. So integrity is again like no matter what the situation is, the device or system should work in a way it is supposed to work, okay. So it should not basically fluctuate a lot from the normal operating situations, okay. So that means that device can be trusted or system can be trusted, okay. And data accuracy and kind of trust both relate to integrity, okay. So integrity, yeah, just remember like there is a boundary for the system to work and it should always be integrated into the same boundary. It should not do too much here and there, okay. And the third one, availability, yeah. So the systems should be accessible when needed, okay. So you don't need all the systems always, yeah. For example, I need my phone from time to time, but then it should be available, yeah. So it should not be like I put it here, someone tried to access from some network, maybe I'm connected to insecure network and then they changed my pattern lock or something else, yeah. So it should be always available when needed, okay, yeah. So confidentiality, integrity and availability, if you are ensuring these three entities, basically you can say you are doing secure computing. And this applies to kind of three entities: hardware, software and data, yeah. It's not only about hardware, yeah, it's about software and data as well. And like I previously have said, so it kind of combines people, processes and technology, yeah. It's not just the kind of technology, yeah. There is some process as well, yeah, for ensuring security, and it combines people as well. So now let's look what is attack and what is mitigation, yeah. So attack means like attacker is trying to attack the system, and mitigation is like kind of a solution to fix that problem, okay, whatever the problem attacker is creating. So why attack happens? I think we already have covered, yeah. So everything is about money, yeah. Attackers want money, or there is someone your enemy, yeah. So you want to shut down their system. You might have heard like there was Iranian nuclear plant. So you know there are countries fighting as well, yeah. So I think US and Israel, they did develop some kind of Trojan horse. They inserted into their system and the whole nuclear plant was shut down, yeah. So sometimes there is enmity, sometimes there is money. So there could be lots of things, yeah. Okay. Okay. So another thing you can say, to get sensitive and confidential information, yeah. And what are the attack effects? So when you can get that kind of thing, so they can basically cause damages, like I already have said, financial, health and emotional, okay. So for example, if your password is lost or you lost some money by someone just transferred, then it's a lot of emotional issues as well, okay. So what could be the mitigations, yeah. So maybe no need to discuss, let's see. So mitigation is timely detection of these attacks and their prevention, yeah. So why timely detection? Because if something happens, if you go to fix, like it takes long time, maybe by that time your data is not just in the hands of attackers, but it has gone many places, yeah. Or it can basically, the whole system can be made basically not working, yeah. So there is something called like denial of service, yeah. So whatever the system is doing, maybe it's not doing that, yeah. So for example, someone may attack my laptop and then I'm not able to move my slides, yeah. So it's called kind of denial of service, yeah. So if a mitigation is needed, so there should be some kind of mechanism in my laptop that detects, like, okay, someone is trying to access this PowerPoint, and then it should stop immediately, yeah, prevent that immediately, or should throw some alert, yeah, so that I can take some manual measures maybe. Okay. So timely detection and prevention is important. Okay. So now what kind of attacks can happen on devices? Yeah. Or you can say this is devices could be computing devices. Yeah. Okay. So in broad, actually we can classify them into two categories. So the first one can be physical and side channel attacks, and another one can be logical attacks. So in physical and side channel attacks, as the name says, there is some kind of physical intervention. Yeah. For example, someone steals my phone, and then there is, like, he kind of do some reverse engineering. Yeah, he takes everything in the memory, what is put in, everything in the browser, and then dumps somewhere, analyzes it, maybe gets my password and lots of other sensitive data. Yeah, so there is kind of some physical intervention, and side channel is called something like, again, some physical properties are used. Okay, we will see some more examples. Yeah, so one example I can tell you here. So it's like basically not directly getting the information from the bit streams, yeah, or the information that is flowing, rather from the physical properties. Yeah. So for example, if you saw I opened a website, right, this poll everywhere, and I typed my password, yeah, but then it's authenticated somewhere. Okay, so there are some kind of mechanisms, like when you type password like A, AB, ABC, all different combinations, the power consumption of that server will be different at different typings. Yeah, like A may be 2 watt, B 2.5 watt, ABC this watt. So all different combinations, they kind of generate different power profile. If someone can get access of that power profile, maybe they can train an AI model, like what should be the password based on different power profile. So this is using the side channel information, not the direct information. Yeah, not really looking the password, but something else that changes the physical property of the device. Okay. Another popular side channel attack is basically, you can say, acoustic. Yeah, sound. Yeah, I don't know if you know. So there are some attacks, like if there is a microphone in your laptop, right? If someone can get access of that, now if you're typing from the keyboard, so different keys have different level of sound. Yeah, because our fingers are differently placed. Yeah, so A, B, C, like if you type in a like proper professional way. Yeah, so if you type A, B, C, S, all have different sound level. Okay, if someone can get access of your microphone, they can get the basically the level of sound that is being generated from the keyboard. Again, from that level of sound, people can detect what is your password. Yeah, so it's from the sound label. So again, this is not directly getting ABC, rather the side channel information, like what is the sound label of different keywords. Okay, then you can get the password. Okay, so those kind of things happen. Yeah, so the first one, like I said, micro probing and reverse engineering can be there. Yeah, you take the device, you probe it, or you reverse engineer. Another one could be these things. Yeah, like I said, someone can do power analysis, and someone, like I said, someone can use the sound label, but there could be other as well. Someone can use timing as well. Yeah, we will see some examples and some approach that in my group we have developed around some of these. Okay. Another branch is called logical attacks. Yeah, like I said, you basically look into the channels, like maybe there is some encrypted data that is going on, and then trying to spoof that and getting the real information from that encrypted data. Okay, so these can be into these categories. So basically, one side you try to basically break the encrypted protocols, and another side could be software attacks. Yeah, virus, trojans. Yeah, like someone puts something in my system, and then this can send some real information outside, or they can simply cause my whole system to shut down. Yeah, so I should not be able to access anything. Okay, So maybe this is not the perfect category, but this is what one of my PhD students did a couple of years back, and this was published in this conference. Yeah, so you can look the paper for more details, and maybe it can be done in a better way as well. Yeah, so this, I won't say this is the perfect. Yeah.
So the attacks that happens during the time of manufacturing, like some people inserting some trojans or something, which category will it come? Will it come in the physical and sexual attack or the logical attack? And is the logical attack being called something like on the algorithm people are trying to exploit some kind of features? Is it that one called logical attack?
So I would say the one you are saying Trojan, yeah. So I won't say it's coming into that, yeah. It's kind of Trojan horse, yeah. So it's kind of being generated at runtime, yeah, because actually kind of depends. So some Trojans, like you say, when things are manufactured, people to put Trojans, right? So if that Trojan is sending some physical properties, then it comes like side channel, yeah. But that Trojan might simply do like initiating something, like maybe lots of packets in the network, and then letting the whole system down. Then it will be some kind of virus, yeah. Okay, yeah. So I think the way it's performed, it can go in either categories. Okay, and the one you said, some people inserting this Trojan, we will cover that into a bit more details. Yeah, I think I have lots of slides on how the Trojans can basically create some kind of attack that can let your whole system down. Okay, and please, yeah, ask questions whenever you have. Yeah, raise your hand, so you don't need to wait, yeah, for the time.
I have a question regarding sound analysis attacks.
Yeah.
How an attacker come to know that which kind of information actually we are inserting? Suppose we have a user text for user information text box, or password we have a text box or something else. How we come to know that which kind of information this time we are actually inserting? Is it a password? Is it a username? Or we are typing something else?
Yeah.
And how we differentiate these sounds, because the alphabets can be same for some text box information.
Yeah, I think very interesting question. Yeah, so for me, I think the attacker is going to get everything. Yeah, maybe username, password as well, and then he is going to make some decisions like whether this can be a password or this cannot be a password. Yeah. So like you said, yeah, like when I logged in into this website, right, I did put username and I also put password. Yeah. So I think the attacker is going to always monitor, yeah, everything, and then he's going to decide whether it can be a password or it can be the username. Yeah. Okay. Yeah. Very interesting. Yeah, I think then attacker has some difficulty. Yeah, so basically you can say defense can be like you also start putting your username in a random manner. Yeah, like it is suggested, you always put your password very long. Yeah, and some random sequences. Yeah, not your name, date of birth or something. Yeah, if you start putting random in the username as well, especially for this acoustic, yeah, sound channel attack, it will be difficult then. Okay, thank you.
Like in sound channel attack, what will the hacker received? A sound wave means a pattern of wave or any kind of alphabet or any I can say 0 1 pattern, 1 0 pattern, anything?
It will receive the sound level. Yeah, it's called like, it's typically in decibels. Yeah.
Okay.
So sound will happen like, for example, I typed here, right, and maybe there is another device next to it. Yeah, so it can receive like the kind of level of sound I am pressing the keyboard. Yeah, or then there could be another program.
Then he need a program to decode that pattern or that sound, right?
Yeah, so that program basically receives the sound label and it sends the sound label, and that sending again can be in the bit format, yeah, like binary format. I think sending will always happen in binary, but attacker knows this is a sound label. Yeah, so yeah, so like that.
Thank you.
Okay. Okay, so now coming to the threat landscape, yeah, what kind of threats can happen on our computing systems, okay. So some of it we already have covered, but we can go into maybe now more formal definitions, okay. So one category can be malware, yeah, so this is malicious software, okay. So what it can do, basically it can harm, exploit or otherwise compromise a computing system, network or device, okay. So this is a kind of malicious software that can be put into your system and can do something that you don't want, okay. And ransomware, I think we briefly looked, it is a kind of a malware, yeah, that is designed to basically get access of your files, access of your system, and then like I said, this is done basically to get money. So if you don't give the money, then the attacker is going to close your system, yeah, in that way, okay. The second category is phishing and social engineering. I don't know if it happens here, but in the UK it happens a lot. So it's kind of representing someone like a kind of a very kind of legal person from maybe government or some insurance company or something. They call you and then they try to basically just get some confidential information, yeah, or they may say, okay, send some money, something has happened to your account or something, yeah. So and now you can see with deep fake and some everything, the voices of even maybe prime minister's voice can be copied or everybody's voice can be copied. So this is again more social engineering, yeah. So this is kind of another category and very popular, it's happening, yeah, okay. So they basically, attackers, they try to kind of resemble themselves as some trustworthy person or entities to trick people into revealing sensitive information and then basically getting the money, yeah. Maybe you have seen some series, Indian series, yeah, Jamtara something, Jamtara, right, it's in Bihar, yeah. It's kind of a Indian series, it's all about getting the credentials of credit cards, yeah, and people is stealing money. So there is a series, maybe you can watch, yeah. So they call like lot of people, sir, आपका account में ये हो गया है, वो हो गया है, I need that last 3 digits and the first 16 digits, and then the money is gone, yeah. They will say open some app, yeah, this app, and then your money is gone. So that series is based on some real events, yeah. I think it's in Bihar someplace, Jharkhand, Jamtara, yeah. I watched it, it's very interesting. So you can see people can be very innovative at small places as well, yeah. You don't need to do very high kind of rocket science, yeah, okay. Yeah, so social engineering is, yeah, is kind of, yeah, getting very popular. And then there could be some insider threats as well, yeah. Oh, sorry. So insider threats, yeah, I think like someone was saying, when these devices are manufactured, yeah, so there could be some insider, they can insert some trojans, yeah. So later on we are going to see the definition what exactly is trojan. So just I will say briefly, it's kind of a circuit that is put into your hardware, but when initial testing is done, it doesn't trigger, yeah. So it's like when maybe the cycle counter has reached maybe 1 year or something, yeah, then it will start doing something and maybe using a part a lot and damaging it, and then the whole system gets down, yeah, something like that. So some insider threats can be problem, yeah. Another thing is like, you know, we are putting lots of IDs, passwords, yeah, it is going into some centralized system, yeah. If there is a person that has malicious intention, he can maybe erase all the data, yeah, or he can sell all the data just to some attacker, okay. So insider threats are also kind of very important, okay. And denial of service is another category, I would say. So this is basically again could happen due to malware or like trojans that can let the whole system down. Okay, so there is some service by a system. Yeah, so denial of service is simply not let that service happen. Okay, do something so that whatever person is trying to do cannot do. So it's denial of service. Okay, all right. Okay, I think I need to go there now. So I have a question. What do you think are the key technologies and practices to handle threats from different landscapes? Yeah. So you saw like we have typically 3 landscape, right? We said edge, the kind of devices and sensors we are surrounded with. Then there is fog, like a lot of servers, and then there is data centers. Yeah. But the security issues that we talked, it can be applied across all the landscapes. Yeah. So I just wanted to kind of see what are your kind of ideas or technologies or practices that you can think of to handle those. Yeah. Okay. So let's go that screen. I also don't know if it's time for a break or something. We will see. Let me throw that question anyway, and then is the pace fine, or you want me to go a little fast or even slower? It's okay? Okay, let's see. Okay, I can see the text box. So yeah, just you can type your question, yeah, thoughts. I think you can also type multiple times. Yeah, if you cannot, I can change the setting. Let me see. Okay, as many times as they like. So you can do as many times as you want. So don't think if you have typed you can't type again. Okay, awareness, good. So 2 people believe in awareness. Yeah, good. I think awareness is very important. Yeah, you might have seen people having annual training. Yeah, I don't know, as a student you do some training, but every year there is some training, like what you should do and what you should not do when you are working. Yeah, it's like you should always lock your laptop when you go, because this could be like information stealing. Yeah, also this is about computing systems, but in a training they also say if there is some sensitive information, sensitive file, always lock your room. Yeah. Okay, anything else you think? Awareness is good example. Yeah. So think about the previous slide. Yeah. So we said there could be several landscape. Yeah. The first one we said can be malware. Yeah. So let's say if someone inserts something into your system. Yeah. So what can you do to stop that? Yeah. And the second one was phishing and social engineering. Yeah. So awareness is for that. Yeah. So encryption is yeah, another nice way. Authentication is good. Yeah. Good. Deep learning. Also authentication, you can see, like, yeah, if there is open network, Wi-Fi network. Yeah. If anybody can connect, it's dangerous. Yeah. And it's also kind of advisable, like when we travel anywhere, right, we always want Wi-Fi, right, and we connect to free Wi-Fi, and there is always a warning, like your data might be seen by someone or something. Yeah. So if you do some training, it is told never use any banking site or something. Yeah. So that kind of thing is important. Access control, yeah, that's good example as well. Like you should not be given access to every system. Yeah. So there are different kind of people who should be given different level of access. Yeah. So everybody should not have administrative right on each system. Yeah, you can install anything, you can delete anything, so that kind of thing. Quantum key distribution, that's interesting. So sorry, I don't work in quantum, so I have less kind of understanding of that. Having multiple layers of security, yeah, I think that's good. Yeah, so I mean, you can say like multi-factor authentication. Yeah, so nowadays you see like in banking websites, right, if you type the password, then next time is you need to put an OTP. Yeah, so that's kind of multi-layer security. Yeah. As advanced cryptography for confidentiality and integrity, and AI for threat detection. Okay, interesting. I think the most popular cryptography you have seen, yeah, AES, yeah. So this is already used. So if something better can be done, better even, yeah. I think AI for threat detection is again very hot topic of research, yeah. So that's very good example. Okay. Layered defense strategy and firewall, yeah. Okay, I think layered again mean like multiple layers, yeah, like I said, this multi-factor authentication. Firewall is another thing, yeah. So you don't basically allow something that you don't want into your system, yeah. I don't know if you guys know about some kind of firewall in China. So in China you cannot open any Google and Facebook or Meta products, yeah. You cannot open YouTube, you cannot open Gmail, no Facebook, no Instagram, yeah. So they have kind of a firewall countrywide, none of these systems can be opened. I travel sometimes China and you can't use even WhatsApp, yeah. So it's very difficult, like they have their own system, yeah. So if you can make something like this, that's also great, right? Like you don't want such websites to operate, though that may not be very secure, yeah. Okay. Good. Yes. Is break 11:30 to 12? And then 12 to 1. Okay, so you already have shown some nice ideas, yeah. So next when we come from the break, we will cover more. I mean, I'm going to kind of maybe repeat some of these. If it is repeated, I will not discuss, but if there is some other points, I will just discuss that. Okay, so next slide is about kind of answer to that. Okay. So yeah, let's have this 20-25 minutes break and then we start again. Okay.